Hey everybody, my name is Silvano Coriani. I'm a PM in the Azure SQL team, and we're going to spend the next 45-ish minutes talking about, again, some of these trending topics like GraphQL and Azure Serverless technologies and so on, right? So the idea for me is to start introducing for people who may not be fully aware of what GraphQL is, describing again the what, the why, the where, and who basically is using GraphQL today. And we will go through how to implement a simple GraphQL service, and we will see how to connect this with Azure SQL and with the other Azure services in the serverless space, and then we will see how to consume GraphQL service from an app, essentially, right? Can be a mobile app, can be a web app, and such. And then we will go through a lot of demos actually across the entire session. Right. So let's start from what, right? So what is effectively GraphQL? So GraphQL is a query language and is a query language for aggregating and query other APIs. It's the original spec was defined by Facebook around 2015 for basically querying structured data offered by a number of services that they were building in the backend. So the reality is that a lot of previous applications that Facebook was creating for mobile apps were not really great in terms of collecting, querying backend services, aggregating data, and showing them in their UI. The UI was executing a lot of independent queries to the backend, and the performance was not really great. So they decided to introduce this new query language, which is a strongly typed one. So basically, you start describing what data, what entities your endpoint is exposing, right? So you have types, you have attributes, and such, and then the query language itself is defining how basically you ask or application asks for the data, right? So there is a query language itself, GraphQL, which is a kind of or could be interpreted as JSON, but it is not actually. And then there's the kind of result sets that you are consuming, which are effectively JSON data fragments that you can then process within your application. If you want to discover everything about GraphQL, I definitely point you to this GraphQL.org link below, and you will see the entire spec and a lot of other information around available libraries and the frameworks in this space. Right. So again, why Facebook decided to invent this new query language. The idea was, we are all familiar with kind of REST APIs and how you can effectively define and design your REST APIs to map, whatever entity you want to retrieve from an application perspective. But generally speaking, those REST APIs, although they offer some degrees of flexibility, they are pretty static, and typically they are centered around a certain set of entities that you want to query. It's from a client perspective, you have very little control on what kind of information you want to retrieve. And the idea with GraphQL was to provide this new language where you can express, the client application can effectively express, what is the shape and form of the data set that you want to retrieve from your endpoint, right? And typically, you want these entities to have relationships between them, right? This is the expressing a graph of relationships is effectively what is behind the graph portion of GraphQL, right? So you have this model which is complex and is expressing those relationships, and you want to have a query language where you can effectively ask your backend endpoint, I want exactly this fragment of the data. And GraphQL is, as I was mentioning, is schema based, and knowing this schema can get exposed to customers, to consumers, and this makes more kind of straightforward to actually query the schema from a client perspective and understand what type of information are exposed, and then what I can query as part of my database or data interaction. There is this problem, this interesting problem of underfetching or overfetching the data, right? So with REST, in some cases, you either have to always return a lot of this connected information from from a design, from a model perspective that you pre-design and you expose, or you have to ask multiple times. You basically have to create multiple round trips from a client perspective in order to retrieve connected entities and consume them from a client perspective. GraphQL is trying exactly to solve this under or overfetching of the data. Basically, the client is in charge of defining exactly what is the data and the shape of the data that are required for that particular operation on the client side. So let me try to explain this with an example. A lot of GraphQL creators and people are passionate about Star Wars, so they decided to create this sample on expressing these concepts of what it means to compare a REST API with a GraphQL endpoints. So with a REST API, let me click on this. Those are two applications that are basically exposing the Star Wars catalog of entities like planets, people, films, and spices, and so on, and you can query, right? So this is an example. This is a classic REST API where I have my entity, people in this case, and I can require a specific entity by passing this index, right? And the result is this predefined JSON fragment that is returning back, where I have my attributes for my people entity, right? And then I may have connected entities, like for example films, where this person is, this character is appearing, right? Species, vehicles, starships, and so on. And from a client application, if I receive this fragment, in order, for example, to get all the details of the movies where this particular character appeared on, it's clear that I need to take this URI and again ask for details, right? So I can take, for example, this portion of the URI and use it here to execute another request. And here you can see you have all the other details that were not present in the previous request. So if I need all of these data points about my character, I need to execute multiple queries. This is not true, though, in GraphQL. So this is another endpoint that is expressing the same data set through GraphQL, right? And it's also showing one of these nice playgrounds. So those are sort of IDEs that GraphQL libraries are providing out of the box to define and test your GraphQL queries. So this is exactly what a GraphQL query means. And here what we are doing is basically we are extracting this kind of information. So basically the entities, the character names in this particular case, out of all the movies that have been released, right? So if I execute this, you can see, what I'm getting back is this fragment, is this JSON fragment where I have all these different information that are combined together in a graph, effectively, right? So this is, and I can change the shape of this graph by basically reshaping the query that I'm asking, right? So there's no need to point to many different APIs, just one endpoint, and basically I can express these different queries. And you can see here we have the schema that I was referring to previously. So client can actually inspect the schema and can understand, discover what are the information that are required, right? So so this is an interesting aspect, because we are, it's in some ways it is similar to other self-describing technologies or data representations, and we can talk a little bit later on to some of these, like OData, for example. So, but where and when it makes sense to actually use GraphQL in our applications. GraphQL, as I was describing, has been created for a mobile app, right? So, it is great actually to use GraphQL in these scenarios where you have to model your client application on top of a set of data, and this set of data can, for example, come from multiple sources, but I want to see that as a single entity or a single set of entities, right? So the natural utilization for GraphQL are those interactive apps, mobile apps or single page applications or web apps, where myself as a user can connect and can consume different data sets by using a simple language, right? So GraphQL is heavily simplifying the design of UI applications, and specifically, the data retrieval portion of UI application, because it's been designed to aggregate existing data services and APIs. And those data services and APIs may have additional business logic and security rules and so on, that in this case are basically hidden from a GraphQL consumer perspective, right? Certainly is not designed for kind of high throughput, highly transactional applications, because the verbosity, if you will, of GraphQL is is contradicting some principles around kind of low latency and high throughput that you may have in some CRUD scenarios where you need to create individual records in your relational or non-relational databases. In fact, when you are in this kind of CRUD scenario, there are other services, for example, OData, other representations of the data that can be more, can be a better fit, right? And there's a great article here from a couple of years ago that is describing why GraphQL is not OData and is definitely targeting different scenarios compared to what OData was introducing a few years ago. So who is using this technology? A lot of companies of all sizes, actually, from small startups to large corporation. And as I was saying, specifically around kind of mobile app development and also web app development, those are the typical scenarios that these companies are using GraphQL for. So let's start talking about some more technical details here. So what is a classic kind of generic architecture of our GraphQL service? So when we create a GraphQL service, we define an endpoint, and in this endpoint, we typically define what operations against our backend data this endpoint is exposing, right? And there are several type of operations. There are queries when we are basically reading data out of one or more services in the backend. There are mutations, where mutations are effectively operations that are changing the data somewhere in our backends. And there are subscriptions. Subscriptions are basically pub-sub mechanisms in order to get notified asynchronously that some data have been changed in our application, in one of our kind of data sets. The client app is basically sending this GraphQL fragment to this app endpoint in a synchronous way, and is retrieving back a response. Who is responding? Well, basically those operations are typically backed by specific resolvers. So this is the official name in GraphQL jargon. And resolvers are effectively methods or functions that are performing some sort of data operation. These resolvers can access a database through classic client drivers, or through ORM packages or higher level frameworks. The resolver itself can query one or more REST services, and then combine the data together to respond back to that original query, or can, for example, query other GraphQL services, or all of them, and combine the results in a single data fragment that will be sent back to the client again. Right. So again, this is the typical scenario where implementing a GraphQL endpoint makes sense. And again, it's not intended as a replacement for other data representation kind of API formats like REST, but again, is intended to be typically an aggregator of these different data fragments to simplify how we are developing kind of the client side of our applications. Some important concepts around GraphQL. The schema definition. So schema is where we are defining our entities. So we are defining both our operations, so queries, mutations, and subscriptions, but also our data types. Right? So the data model that we want to expose through our GraphQL endpoint. One of these entities is the set of queries that we are exposing, and queries are just, as I was saying, basically what type of entities and how we are going to retrieve entities through the GraphQL endpoint. While mutations, as I was saying, are all the data modification operations that we can think about, right? So typically mutations are expecting some sort of input, a set of input data points. Typically, we are using input entities to provide, the set of data required by this data modification operations as one. And then typically mutations are replying back with the data that have been changed in the system. The resolvers, again, are those methods or functions within our GraphQL endpoints that are effectively implementing whatever kind of data interaction or data access logic that is required. And of course, there are a bunch of more advanced topics and concepts here. For example, we may want to optimize the way our GraphQL endpoint is loading data, is retrieving data from multiple services, so we can implement one data loader, one or more data loaders. We can implement caching so that not all the entities are retrieved every time a client is asking for. Of course, we can support, or we have to support, things like pagination for larger result sets, or filtering, the ability to express from a query perspective more complex queries that will be transferred to the backend kind of data store that is targeting that particular resolver. And of course, from a security perspective, we can implement authentication authorization mechanisms on top of some of the major frameworks that we will see kind of later on. Right. So how we can implement this GraphQL service? Well, it's quite simple. So we have a bunch of frameworks that are pretty popular in this space for all the major languages. Actually, this session was initially conceived for kind of cross-language type of kind of audience. For now, today we will focus on .NET, but we can see also some other examples using Node or different languages that are using these different frameworks. Like Apollo is probably one of the most famous one, and is very popular on Node and JavaScript and TypeScript developers. Graphene is for Python developers, but there are a lot more. In the GraphQL.org website, you will see a bunch of very popular frameworks available for you to start kind of developing your own applications. So let's start by the schema, which is one of the most important aspects here. So what we need to do, first of all, we define those root types that, as I was mentioning, are usually referred as operations. So queries, mutations, and subscriptions. Those are typical kind of objects from a GraphQL perspective. Those are root objects because they need to be there in order to create a GraphQL service itself. And then you have all your entities, your object types that are describing the various entities that this GraphQL endpoint is manipulating. These objects typically and those operations have arguments, so can be scalar arguments or can be other object types. Those objects can be in lists, organized in lists and arrays. There are some input types that again are conceived to be passed to mutations in order to give the mutations the data necessary, required to create those data manipulations. You can extend object types by adding new capabilities and so on. We will see later on a little bit more about this in a live example. And those root types that I was referring to are super important. The query types represents again this kind of view on the entities that we want to expose, and client applications can shape what kind of objects and attributes they want to retrieve, so they don't need to change something on the server side just because we need a different shape of the data to consume. And queries can have parameters, can define filters, can implement sorting, can contain those queries kind of sorting hints and so on. So it's a real query language at the end of the day that we can provide. And the mutations again are those data changing operations where we are passing an input. The resolvers will change the data in the back, and then the new data will get returned back at the end of the mutation. And subscription again are this kind of notification mechanism where other applications can be notified if a certain set of data have been changed or certain operations have happened on the back end. Okay, so let's take a quick demo for now. So first of all, I have a bunch of demos in my repo. The repo is linked in my slide, so you will find that. So let's start from a very introductory one, and again, this is a .NET app. I'm using this hot chocolate framework that, in my opinion, is one of the most advanced ones in the in the .NET space. Actually, Hot Chocolate also provides provides a template which again can be downloaded and installed on your dev box, and then you can just say .NET new GraphQL and it will create a simple, the simplest project possible. I started actually from that project in order to create this little app here, right? So what it creates is basically using the ASP.NET Core stack, right, in order to and some specific hot chocolate middleware to create our own GraphQL endpoint, right? So let's take a look at what are, from a coding perspective, the important components here. So first of all, we need to declare a bunch of services in our ASP.NET Core app. This add GraphQL service is basically injecting the hot chocolate middleware in the ASP.NET pipeline, and then you can start adding your root types. So the query type, the mutation, and the subscription, right? And then I have, of course, three objects in my three classes in my application, and we will take a look at how that are implemented. And the other change that we need to do here, instead of mapping the endpoints to the classic pipeline, we basically are mapping the hot chocolate middleware I'm doing this at the kind of root of this web app, but typically there's a GraphQL route that is the default one, right? So let's take a look at the query, which is I think one of the most important. So we need to have this query class, and then we have this resolver method. So the resolver method is basically using some magic behind the scene, or in this case is basically exposing an entity called person. Right, so the get person is just a convention that all these methods needs to have to be treated as resolvers. Of course, you can write more complex code here to change those conventions, but by default, this is what you can do with kind of your code first approach, right? And this is just returning back one entity of type person, and we have kind of Luke Skywalker here as a return, right? Let's, this is the person entity with name and age attributes, right? So let's start running this. And we will start seeing what the hot chocolate framework is giving us. So first of all, the interesting thing has this kind of integrated IDE as we were seeing before. This is slightly different from the previous one, where we can effectively start writing our queries, right? So and we can expose our schema definition here. So in this case, as you can see, we have one type query, one type mutation, one type subscription, and this type query is returning a person entity. Okay, so let's go back to our operations. So those were other queries that I was using for subsequent demo. So let's create a basic one, and what I want to expose is my person, right? And for this person, I want only to express, basically retrieve the name. Okay, so I don't care about the age in this particular case. So I'm basically defining this query, and I'm getting an error because it doesn't like this having multiple queries here. Let me try again. Okay, here it is, right? So this is the data fragment that I'm getting back. This is a JSON response, as we see. And this data fragment is basically containing only the name. If I want to retrieve more, for example, the age, you see, the GraphQL engine is basically retrieving me the entire entity, right? So this is the interesting thing, right? I can effectively, the client side is in charge of defining what data points will get returned, right? And same if we want to execute another operation. Let's take a look at what other operations our application here is exposing. Our mutation here is called add person, right? And this add person is expecting a couple of parameters here, name and age, right? And what this is doing basically, I'm just, I mean, this is again a data modification operation, right? So it's intended to kind of persist this new entity in a proper data store, a proper database. For the sake of the demo here, this was not strictly needed. So I'm just returning back the created one. And what I'm doing, I'm also using the send async, which is the way we are notifying a subscription, as we will see later on, that this operation has occurred. Right, so let's go back to our demo here. Let's create a mutation this time. And this mutation is called add person, right? Add person, and is expecting a name, OB1, and an age, right? Which is, I don't know, 99, okay? And what I want back is, for example, the name of the person that I just created, right? So I'm executing this, and as you can see, the GraphQL endpoint is replying me with the operation that have been executed and the information that I just inserted in the database. Okay, so what we can do here is let's open up a new one here, and let's see what subscription we created here. Our subscription is called person added, right? Yeah, person added. So what we can do here is, and what we want to understand is what is the name of the person that have been added, right? So when I'm executing a subscription, basically the client is waiting for that person to get created. So if we go back to our mutation, let's execute a mutation here, and in the other, let me see. We may need to refresh this, re-execute, and for whatever reason is not working now. I may have messed up my environment by creating multiple multiple versions and stopping and recreating my my project here, but nevertheless, so what we should have seen there is that the client who was basically executing that subscription code would have received that event when the mutation was executed, right? And what we are using here behind the scenes, let me stop this for a second. We will see this in the startup. Subscriptions are based on WebSockets, right? So we have the use WebSocket configuration here in our application builder in the .NET stack, and in order to keep those subscriptions, we have a couple of options. We can use this in-memory subscription engine which is offered out of the box, or we can use a Redis subscription Redis engine in order to keep track of these different subscriptions that have been created and subscribed by a bunch of clients. Right. This was the simplest one, and for whatever reason now I kind of messed up the environment right now. But again, this is the simplest simplest GraphQL service that we could implement. Is almost like a kind of .NET new something, and you will get most of these implemented for you. Now let's move to how we can integrate this with Azure SQL Database, right? Basically, we are just implementing our own resolvers, and in our own resolvers, we can create whatever code is required to connect to our database. And the resolver will basically transform back the results into a JSON fragment that can be consumed by clients. We can create those resolvers using client libraries, so SQL client, using something like EF Core or another ORM, and the model that we create within our context will basically get exposed as a GraphQL model in the schema, and we will see how that works. Right. That said, the way we are implementing those resolvers, all the best practices and the good practices of accessing data still applies here, right? So of course we using parameterized queries, storage procedures where it makes sense, for example in mutations, privilege kind of batching for kind of multi-row operations, leverage connection pooling. Not kind of a big news in this sense, but it's super important because again, our GraphQL endpoint will only be good consuming our relational data if our data access code is implemented properly, right? So let's take a look at a slightly more complex scenario here, where I'm starting to access my backend database in Azure SQL Serverless in this case, right? Because we want to show a fully serverless platform here, right? So, this is exactly what we've been seeing previously, right? So, what I did here was to create a simple model. I have a DB class, and the DB class is basically implementing our resolvers. In the DB class, I'm just using Dapper in this case. And for example, I'm retrieving orders. And when I'm retrieving the orders, I want to retrieve also what customer and what order lines are connected to that, right? So I have a simple query here, relatively simple query, which is extracting those different information. And then what I'm doing with Dapper, I'm just populating this order class here, which is again, let me, one of our base classes. These are the classes that I'm exposing in GraphQL, which contains a bunch of data coming from our order table, from our customer table, and from our order line table, right? And then I'm combining all of this and returning back to the customer. At the same time, I also have a mutation that is adding a new order line to my backend, right? And this is a mutation. This is an example of those input objects, input types, and in this case, it's just a new record where I'm taking all these different parameters that the client is passing. I'm combining this into this record object, and I'm just sending it to my backend database. So this is how typically mutations are implemented. Right, so let me now take this, compile it, and here it is. So let's change and go back to our query. This time I want to get an order. I want to get the order number 1, for example. Okay, and I want to retrieve, the order date, for example. I want to retrieve from an order date. For example, I want to retrieve what order line. Oh, sorry, not order date. Order date is a field. I want to retrieve the collection of order lines. For the order lines, I want to get the order line ID, the product, and the quantity, right, that have been ordered. But I also want to understand, what customer actually created this order, right? So I want to know the customer ID and I want to know the customer name, right? So here you can see, you can start perceiving, what type of complex queries the client can actually design and require data points for us, right? And if I execute this, here it is. This is the JSON fragment, which is effectively returning my order information, the order date, the order lines, and the customer information, right? So not all customers actually wants to create wants to use this kind of boilerplate code here with SQL queries and such, right? So let's quickly take a look at what means using entity framework instead of creating custom resolvers. When we use entity framework, again, I have my entity framework model here, which is quite similar to the previous one, right? But this is my DB context. In the DB context, I'm just exposing my collections. Nothing new here, pretty straightforward. But what we are doing here differently is, and let's go to the startup. So first of all, we are basically injecting our model in the ASP.NET Core ASP Core pipeline as a pooled set of contexts here, right? And this pooled set of contexts will be used in our queries because again, multiple threads can run at the same time, and they will pick up just one of the copies of the context that we have in the pool. And if we look at our query here, how this is designed, you will see, you can see that there are some changes compared to the previous one, right? So first of all, we can actually inject some of those capabilities like filtering, sorting, paging by leveraging attributes here. And this get customers one will become, and get order one will become our resolvers, right? And then we just basically pass back our entity framework, our link queries to our entity framework model, right? So in this case, let me run it, and we can quickly see. We actually should see the exact same result, but we can actually see more, right? So let me take the previous one. I'm just using a slightly different IDE. Why? Not sure why is in. Oh, got it. This is a different. Here it is. So this is the response to the previous query. I'm just the resolution here of my monitor. Here it is. Okay, so this is the query that I'm executing, and let's try just for the sake of. You can see all kind of the different type of orders that are coming in. But what I'm doing here, if you may have noticed that I'm also using this creating this resolver called get customers, where what I'm doing here, basically, I'm using paging, filtering, and sorting. This means that what I can do is, for example, retrieve aggregations, right? So this is I'm basically extracting from my customers collection how many customers there are, and I'm also retrieving the initial top 10 customers out of the database, right? So I have to do execute here, right? So this is a different option that we have. Again, I didn't wrote any specific resolver for this, but the integration of Entity Framework and the Hot Chocolate GraphQL server is basically offering me to expose my data points in a different way. Right? So, for example, this is an aggregation of basically select count of all my customers, and then I can retrieve a bunch of nodes. And if I see here in my debug console, what I'm doing, I'm just logging out what kind of queries the entity framework model is executing. And you see we have this select top, and this is because we are skipping and we are using paging, and we are sorting, and then you should see actually here also the select. Here it is, the select count, and again, this is where we are basically aggregating all the records in this particular table and executing the count function on top of that, right? So again, this is an example of what can be done here. Now, what I also have here in my example is from this exact code that I have here, I just created a function, an Azure function locally here, right? And this function is something that I can then post in my public Azure subscription, right? So it's exactly the same code as you will see, with some caveat in terms of the hosting model, because here we are hosting in Azure Function. So we are using actually a slightly different method, and in particular, we are using a proxy in order to loop the GraphQL engine into Azure Function. But once we have been doing this, things will continue to work as expected. I'm doing a simple demo here with the local Azure Function Engine and tools in order to prove you that things are working this way. And I'm using actually Postman in order to demonstrate that, just because with the Azure Function Engine, we cannot show the embedded IDE that I was showing previously. But here is the function endpoint local that I have, and if I execute this, it should, down the runtime is likely is picking up, and here is the result that now is much faster as the function runtime have been created, right? So you start by developing your GraphQL endpoint. You create your Azure Function project, and now what you can do, for example, is you can use. Let me see if I already have that command. Yes, what I can do, I can use the Azure Function tools and publish my GraphQL function in Azure Function. My code here will get packed and will basically get installed in the pre-created Azure functions that I have on my PC. Actually, on my Azure subscription here. One last thing, I want to show you that Azure Function actually working. Here is the function that I published. And let's give it a couple of seconds. Okay. So again, I have my order and order line, my Azure function here. I'm executing my code, and you can see, my fully serverless GraphQL endpoint with my backend database, which is, by the way, a serverless one, right? So this is the resource group that I created. You can see I also have another example here, which is the same app containerized and loaded up in a container instance. Let me show you this as well, if I can, which is another alternative actually that we have. Here it is. So this is exactly the same code. I have this Azure container instance where my GraphQL endpoint is running. Let's see, and it is working actually, right? So you see changing the order lines and so on, right? So just to close up on my presentation here, the serverless options that I show you in the demos, I think those are the most interesting ones, actually. Azure Container Instances is probably the simplest one. You just containerize your app and you push it to a container registry, and then you can deploy it on Azure Container Instance. But you are still in charge of maintaining things like your container images, if you have to patch it, to version it, and so on. And also, the moment you have to create the entire end-to-end solution, it does require some kind of gymnastic in order to glue containers together and so on. Azure Functions, as we have seen, is probably the full serverless, the most serverless experience you can achieve, right? And you basically can rely on the entire Azure Function infrastructure to create your app. Or if you are deploying a end-to-end application, including UI and so on, Azure Web Apps are likely another great option that you can use, right? And again, combination of these technologies with Azure SQL Serverless will give you this serverless platform to host the entire service for you. So again, GraphQL is this great framework where you can design your data services interactions for applications, right? Applications can consume GraphQL endpoints, bringing data together, and it works well with existing REST and other data services like databases. The main goal here is to reduce application round trips and make sure that the client can bring all the information they need in a single operation, and then populate the UI and so on. And again, it works well with Azure SQL DB through client drivers, ORM frameworks, and such. Right. Just one last demo before closing, and I wanted to show you how a client app can actually consume one of those endpoints that I just created. Right. Again, there's a bunch of existing packages and out there. I'm using this here, the GraphQL client package. And in my application, what I'm doing here, I'm just writing down the query as a simple text with some variables, and then I'm using the GraphQL client, sending my query to the server, to the endpoint. The endpoint that I'm using right now is the container instance endpoint that I previously showed, and then I'm just showing the results coming from there, right? And I have a strongly typed response actually, where I can navigate my order data, my customer data, and let me do a quick .NET run. And here I'm showing the raw response, but because we are actually mapping an existing .NET type to the response, I can also access my data through my object instances and properties and so on, and the client app can then manipulate the data for me, right? So I think we quickly had this kind of end-to-end rapid experience around how to define our GraphQL endpoints, how to host GraphQL applications in Azure and Azure SQL Serverless, and then how to consume from a client perspective. I'm looking forward to hear your questions if there are. Otherwise, again, you will find a link to my samples in the GitHub repo that I share with you.
Yes, thanks a lot, Silvano. Really insightful, and yeah, quite a nice journey with the demos and everything. Even Florin got it.
Yeah, I even got it. So I now understand how you do GraphQL with and what the serverless options are on Azure.